Fundamental theorem of calculus. There are two parts to the fundamental theorem of calculus. The first part is that the integral or integrating is the opposite operation of differentiating. So basically they undo each other. So we can show this here. If we take the integral of f and then we differentiate it, we should get back to that same f. Okay, so the in math, we have these opposite operations like add and subtract, times and divide, squares and square roots. So the integral and the derivative can be thought of as opposite operations, just like those other opposites are. So they essentially undo each other. So that's part one of the fundamental theorem of calculus. The other part of the fundamental theorem of calculus, or part two, would be that the area under the curve represents the displacement on the antiderivative. So if I can write it this way, so the area under F is the same as the displacement on the antiderivative function. Okay, so the area under F, and we need some bounds here. So the area under F between A and B is going to be the displacement on the big F, or antiderivative function, from A to B. So these are kind of the main ideas of the fundamental theorem of calculus, those two parts. There's also this other part that we actually want an antiderivative function. We actually want the function fx and not just the displacement. So we can use this to kind of define an antiderivative function. And we can think of it this way. So we have our f function. We're going to call that f of t, some function. And we're going to say that the area function, or the big F, so we're going to say that the area is a function of x, where the area has a specific starting point, and it has some general ending point, x, and that point can move to the left or right. And in doing so, that will generate different amount of area. Okay, so I'm just going to shade that in here. So this area can be found by moving that point left and right. So we're going to call that a of x. That's going to be a of x, area as a function of x. That is our antiderivative function that we're going to call f of x. Okay, so there's two parts to the fundamental theorem of calculus. The derivative and antiderivative undo each other. The second part is that the area under the curve of f of x, the area under the derivative, is the displacement on the antiderivative. And from that, we can also say that we can define an antiderivative function as the area from some arbitrary point A to some fixed point A to some point x that can move. And as we move that x, it will generate different area. And so the area becomes a function of that x.